Have you ever wondered how data is grouped in machine learning? Today, we will explore this concept. In the world of machine learning, a fundamental technique for organizing vast amounts of data is known as clustering. It's the task of grouping a set of objects in such a way that objects in the same group, or cluster, are more similar to each other than to those in other clusters. But how does this happen? Well, there are several ways to approach clustering, each with its own strengths and weaknesses. These are executed through algorithms, step-by-step procedures for calculations. From k-means to hierarchical clustering, from density-based spatial clustering of applications with noise to mean shift, each algorithm presents a unique way of tackling the challenge of grouping data. Each comes with its own set of rules and methods for creating these groups. So, are you ready? Let's dive into the world of clustering algorithms. Starting with the k-means, a popular and simple algorithm. It partitions data into distinct clusters by assigning each data point to the nearest cluster centroid. The process is iterative, recalculating the centroids based on the mean of the data points in each cluster. Its simplicity and efficiency make it a go-to choice for quick and dirty data analysis. Transitioning now to hierarchical clustering, a family of algorithms that constructs a hierarchy of clusters. There are two main approaches, agglomerative and divisive. Agglomerative clustering begins with each data point as an independent cluster, gradually merging the closest pairs until only one cluster remains. On the other hand, divisive clustering starts with all data points in one cluster, recursively splitting it into smaller clusters. This method is particularly useful when we're interested in multi-scale clustering structures. These are just two examples of how we can group data, but let's explore further. Now let's talk about DBSCAN, a density-based clustering algorithm. DBSCAN stands out from the crowd because it doesn't require us to specify the number of clusters in advance. Instead, it identifies clusters based on the density of the data points. The algorithm works by grouping together closely packed data points, creating a high-density region. But what about the data points in low-density regions? Well, DBSCAN has a clever trick up its sleeve. It marks these points as outliers, setting them apart from the main clusters. We then move on to the mean shift algorithm. This technique shifts each data point towards the mean of the points within a certain distance. By doing this, mean shift effectively finds the modes of the data distribution. These modes represent the clusters. These algorithms provide more flexibility in handling different types of data, but there's more. Next up is the Gaussian mixture models, a probabilistic model. This model assumes that the data is generated from a mixture of several Gaussian distributions. It uses an expectation maximization algorithm to estimate the parameters of these distributions and the probabilities of each data point belonging to each cluster. Quite a fascinating approach, wouldn't you agree? Now let's move on to optics, a density-based algorithm quite similar to DBSCAN. This algorithm produces a hierarchical clustering based on the density reachability of points. This means it can reveal significant structure hidden within the data, making it an excellent choice for complex datasets. Last but not least, we have agglomerative clustering. This method is a hierarchical one that starts with each data point as a single cluster and merges the closest pairs of clusters until only one cluster remains. It's a classic yet highly effective approach. And there you have it, a brief introduction to some of the most commonly used clustering algorithms in machine learning. Remember, choosing the right algorithm depends on your specific task and the nature of your data.